Alright, so the purpose of this video here is if you had a little trouble today in class and maybe we were moving a little too fast and you couldn't catch what I was saying or you didn't get a chance to answer your question, ask a question, here is your opportunity to see it a little bit more at your own pace if you need it. So we talked about a couple things. The first thing we talked about was expanding our production possibilities curve here. So notice this is a country and they are choosing between guns and butter, which is like a classic economics example for your production possibilities curve. You can either choose food or you can choose defense. Two very stark choices that all countries have to choose between. How much you can spend on your guns, how much you can spend on your butter. Or more accurately, what resources will you dedicate to each. So imagine for a second if we had a technological innovation like a new tractor or something. The tractor might help us make more butter, more farm products, right? But it probably doesn't, it's not going to help us make more guns. So your production possibilities curve might go like so. So you're making more more butters, but not any more guns. Consequently, maybe you have an innovation that affects both of them, right? And then you would get a curve that looks more like this, where you make more of both. And you could also end up with a situation where you had just an innovation that made more guns. I can't really think of one off the top of my head, but just a better gun-making machine. All right, well, then it wouldn't affect your butters. And I realize my lines stink here. I apologize about that. But you're making more guns in that situation and no more butters. So hopefully that kind of reinforces what we talked about at the beginning of class. Now, one thing that we didn't necessarily talk about, or I'm not planning on talking about it, is can your curve move inward like this? Well, maybe. We hope that it doesn't, because we're trying to make our economy grow over time, and that means the production possibilities curve is shifting outward. We're producing more with our resources. We're getting more efficient and better. But it's possible, maybe, for our production possibilities curve to shift inward. Can you think of a time when maybe that happened? Well, maybe like after the Second World War in Europe. They destroyed so many machines, so many factories. The land was ravished. It was just a really desolate place, right? So maybe they, after the war, could not produce as much. That might be possible. Or maybe the South, after the Civil War, maybe. The same thing. Or maybe certain places where they have really nasty natural disasters. Maybe like New Orleans after Hurricane Katrina. Or some countries that have had like massive earthquakes or something like that. And all your resources get just torn to shreds and you can't produce. Maybe that happens. Not normally a question you see on the test, but something to think about. All right? So if you have any questions about how the curve kind of expands or shifts, let me know and I'd be more than happy to help you out. Now the next thing we did was we said, okay, now you got a production possibilities curve here. And we want to talk about, well, we're going to compare actually two countries. Well, I only have one production possibilities curve here right now. But let's make a second. I'll go like this, all right? So this one here is country A's. This is country B. And they both have different abilities to make things. Now, we want to figure out who should spend time doing which thing. So what we have to do is first we got to convert this information on the graph into this chart to help us out a little bit. So country A, they devote all their time to guns. They can make 30 of them. Okay. If they devote all their time to butter, they can make 30 of them. Now this is going to make our calculation here really, really simple in a second for country A. Also remember that you can't use a calculator, so the numbers are going to work out easily most of the time. If they don't, you want to probably go back and reevaluate and double check your work. Now I just did B while I was talking there, but B again, they make 32 when they devote all their time to guns, but they only make 10 butters. So that's why I got 10 here. Notice these are or statements. It's not that A can make 30 guns and 30 butters. That'd be like a point like up here. And right now for country A, this is impossible. Okay? But they can make 30 guns or 30 butters. Now to remember your opportunity cost here, how are you going to find it? We got to figure out if this is an output or an input problem. Well, this is a production possibilities curve. It is telling us how much stuff we can make with our resources, our inputs. So when it tells us how many products we can make with our inputs, this is an output problem. And And all production possibilities curves questions are output problems. So output, the rule is other goes over. And you got to be careful here, because sometimes your products might be on the top. So guns and butter and A and B might be switched. In which case you got to be really, really careful about what number you're going to choose to go over. So here, country A can make 30 guns. So the other number is A's other number, 30. So excuse my handwriting. 30 over 30, that means 1 butter. So the cost of making a gun is 1 butter. Now we do the same thing. Well, we're at 30 butters for A. Their other number is 30. So 30 over 30. And this is not 1 butter now, but 1 gun. So when they make a butter, they give up 1 gun. And this should be true because the reciprocal of 1 is 1. Remember, these two numbers will always be reciprocals. Now this one over here, if we go to B, the other number, if we're at 30 guns, for B is 10. So we go other goes over. I think I actually wrote that wrong over there, so I apologize. I should have done it. It didn't end up affecting my answer, but so like this. That goes over. 10 over 30 equals 1 over 3 butters. Now here you're at 10 butters. The other number is 30. It goes over 30. That looks horrible, but 3 guns. Okay. Now, this is the part where you got to kind of change the way you look. So this time we went, to figure out our opportunity cost, we went up and down here, using our rule, other goes over. Now we need to compare the cost. Well, what's the cost for A when they make a gun? It's right here, it's 1 butter. And the cost for B is 1/3. Well, the question is, we want to do things that cost us less. So, who's got the lower cost for making a gun? It's B. They're at 1/3, right? 1/3 versus 1. 1/3 is smaller. So they should be making the guns. Now, go down to the butter. Compare what are the costs for your butter? 1 gun, 3 guns. Well, 1 is smaller. So A should make the butters. This means that A is going to export butter, and B will export. Sorry about that. I don't even know why I tried to write with this thing. B will export the guns. So another way to say it is B will specialize in guns, and A will specialize in butter. So remember, if it's an input problem, they tell you that, hey, it takes a certain amount of time or a certain number of workers to make a product. That's an input problem, and the rule is other goes under, IOU. So again, I hope that kind of helps you a little bit if you were struggling a little bit. Again, if you have any questions about how to do this, by all means, let me know. Have a great day.